Welcome back here. We're going to continue our look at the properties of logarithms. All right, and we already established two here for the log base 10, which is log of 1 equals 0, and that log of 10 equals 1. And then for property 3 here, we're going to do a more general kind of property where we have log of 10 to the r equals r. Okay, this is just a generalization of this form right here, where we have specifically the power of 1, now we're going to have the power of r, so that includes 1 as well. So let's go ahead and do that. So we'll use a similar argumentation to what we did for property 2 here, where if we have log of 10 to the r equals r, remember that is the same as log base 10 of 10 to the r equals r. So again, writing it in equivalent exponential form, 10 to the r equals 10 to the r. So check that's going to be true, so this will also be true. Okay, the next property here, for any x greater than 0, 10 to the log of x equals x. So this one might be a little bit harder to see, but I'll show you here one way to think about it. Okay, in this situation, right, what we can do to kind of take care of this is to take the log, I'll do this in a different color, we'll do the log of each side. Okay, remember log is log base 10. Okay, log base 10 of x is just going to give us log base 10 of x, right? That's not going to change. You can't really simplify that at all. But in this case, right, well, we can use this property right here because we have 10 to a power, right? Just like we have 10 to the r here equals r, we have 10 to the log of x. Okay? And so what is that going to simplify to be? Well, it should just be log of x according to this property right up here, right? It becomes just the power, and the power in this case is log of x. So we get log of x equals log of x. So check. That's right, because again, this is also log base 10. Okay, this property right here, where we have log of x times y equals log of x plus log of y. Okay, how are we supposed to do that? Well, let's start again with log of x times y, and we'll say, is that equal to log of x plus log of y? And what we'll do here is we will raise each side, we'll do 10 to the power of the left-hand side, and we'll put the right-hand side as an exponent of 10. So it's going to be 10 to this power and 10 to this power. Okay, now, using our properties of logarithms, we just saw here that if we have 10 to a logarithm, right, 10 to a logarithm, it simplifies out and leaves you just with the x was inside there. So this will simplify out and we're left with just x times y. Okay, and then in this situation, I'll take a little bit more steps here. If we have 10 to the log of x plus log of y like that, but remember the exponent properties here, that if we have if we have something like 10 to the third plus 4, that's the same thing as 10 to the third times 10 to the 4, right? Typically we go from this direction and arrive at this, right? If we multiply two things with the same base, then we add the exponents. Okay, so we're just breaking it apart. We're starting with the addition and breaking it up into 2. So this is really the same as then, I'll put it over here, 10 to the log of x times 10 to the log of y. And now these both simplify. The 10 log and the 10 log cancel, and you have x times y equals x times y. So check that works. Okay, number 6. Property 6 states for any positive or real number x and any real number r, log of x to the r equals r times log of x. And we're going to use a similar exponential properties here too. It tells us, right, to use an exponential rule as well as property 4. So log of x to the r equals r times log of x. And again, we'll do 10 to the left-hand side and 10 to the right-hand side. Okay. These 10 and logs will exactly cancel. We're left with x to the r. And in this case, again, we have a product. Okay, so when you have a product and an exponent, right, we have 10 to the r times log of x. Okay, or we could also think of this as 10 to the log of x times r, right, where the r is flipped around with a log there. Which, when we have multiplication, that means it's the same thing as a power to another power, right? We could write it like this. the 10 and the log x cancel. The 10 and the log cancel. We'll just have the x. We'll have x to the r equals x to the r. So check, it's true. So in general, if you take the logarithm of a number to a variable, you can bring that variable out front and multiply it with your logarithm. Okay? And then number 7 and 8, we will apply those properties to write things as a single logarithm or to rewrite its expression as a sum or difference of logarithms too. Okay, so we'll see you in the next lesson.